I'm recording for Dean. Okay, so our objective, I repeat again, just for Dean. So our objectives are Harus. This one is what happened? They don't connect. They're not filling it. Okay, anyways, the objective is number one. I'll tell Dean first. Objective is we're gonna learn circles. And then number two is we're gonna do example 4 to 9, right? 4 to 9 of the worksheet. So 4 to 9 of the worksheet. Question number 4 to 9 of the worksheet. Yeah. So it's in class, but if you cannot finish, then it will be homework. Yeah, that's about it. Okay, let's see how much we can learn today. Okay, so today we're going to learn circles. Now, when it comes to circles, right, what do you think is so important about circles? This is totally not a circle, but I circle on my screen. Okay, so what do you think is so important about circles? There's a crucial thing that you need to know about for circles. Two crucial information. What? Okay, radius. But before radius, we need to know something first. Before radius. Very good. So we need to know the center. So this is the center. After center, then we have this thing called the radius from here to here. So you need to understand, right? For circle, the radius is the same throughout, okay? But I didn't draw accurately. So more accurate means it's from center to the circumference is the radius. Now, as long as you know these two information, for circle, you can do a lot of questions. So the two formulas you need to memorize for circle is already in your notes. So what are the two formulas in your notes? The first one is?
X minus a squared.
Okay, so the first formula that you need to memorize, it's x minus a square, the whole thing square, then?
Plus
Okay.
y minus b squared. Those are squared.
Yes. Now, from this formula, you must know how to achieve this formula, okay? The first formula and the second formula. So the first formula, let me type space, write it down. Okay, so for the first formula, right? What is happening is that you need to know how to identify the radius and the center. So to get the center, means the one in red. I'll just write center first. So how to achieve the center? The center, right? There's a trick to achieving the center. That means that over here, can you see this? The goal is to make this person 0 in the bracket because x minus a is equal to 0. So I know that x is equal to a. So this person is a. So please be very, very careful. Can you see the x minus a one? It needs to be a negative, okay? So if let's say it's over here is x plus 5 squared. So what is the x coordinate of the center? Yes. So you can either see if this positive means here will be negative, like -5, for example. Or another way you can do is your side working. X plus 5 is equal to 0. So you know that x is equal to -5. Both ways is the same. You guys got it? Okay. So that is for the center. It's same thing for the y coordinate is also here. So just make sure that this whole thing you see becomes 0. So this one is your B. So now how to get your radius then? So your radius means you just take this person and square root it. Okay? So if you want to work the reverse, means you go and square it. So you square root it, means you square root the r square, you get r. So that is the radius. For example, sometimes they say blah, 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 blah is equal to, maybe they don't put r square, they put as 25. So what is your radius then? Your radius you need to know is actually 5. Got it? Yeah. So you guys can put it in your notes and color code the same thing. So for center is in red and for the radius is in purple. And don't forget to put the mark that is you want to get the radius is to square root it. Yeah, give you some time to make your notes. Over here, right, the first formula, can you put a bracket? This is called the general form. Not general form, sorry. It's called a standard form. And then this is called, the second formula is called the general form. So just in case if sometimes your teacher say, express the equation as a general form, then you guys would know what your teacher actually meant, okay? So these two you have to memorize. The standard form and the general form. So what is the general form next? So the general form next, you can see in your notes, it's actually x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Okay, so be very, very careful. Now I want you all to take another color pen and please put a star for this general form. Now, to use this general form, you must always make sure that your coefficient of your x squared and your y squared must be 1 or plus 1 to be exact, okay? Because sometimes the question is very tricky. Some school question, right? They like to put a 2x squared, 2y squared, for example. So you need to go and modify it and divide everybody by 2. You guys got it? So if you don't divide by 2 or you don't divide by whatever that the question wants, right? Then you will get it wrong. Yep. So be very, very careful about this. This is one of the tricky exam questions that I've seen that student cannot score because of that. Then in the end, instead of getting 4 marks, you get 0 mark. Because this very first step is already worth 1 mark. Yeah. Okay, so for the second formula, this is a general form. So how to find the center? So to find the center, I'm going to leave some space and please put it in your marking. It's actually negative g comma negative f. But you don't really need to memorize this negative g and negative f. You just need to know, can you see this is a coefficient of the x? You just take the coefficient of x and divide by negative 2. Then you take the coefficient of the y and just divide it by negative 2. Okay? Just remember this. And then you will naturally get your center. So you guys can go and make your notes. Negative 2, negative 2. Now the next one we're going to do is to find the radius. Now the radius, right, the formula is more complex. You need to take the square root of f squared plus your g squared minus c. Now it doesn't matter who is your f squared or your f squared or the g squared, because right, your f and g, whether b is positive or negative, when you square it, eventually you still get a negative answer, correct or not? But your c, you need to be very careful here. This is the c that you need to be very careful of. Can you see this c? So this c and this c, right, they are always opposite signs. So with that, all this precaution, you guys are ready to go and do your standard form and general form in question 4 to 9 of your worksheet later. Okay? Okay. And clear screen, right? Now the next one we're going to learn is discriminant. It's in your notes, the first one on the bottom right. Now, what about this discriminant? How do you link discriminant to circles? Can you see here in your notes? So this one cuts at how many points? So the line cuts a circle at 2 points. So it cuts a circle at 2 points means what's your discriminant? B square, oops, minus 4AC will be greater than 0. Can you see that? So for your notes, all you need to do is you take your highlighter, go and highlight the 2 points and then highlight greater than 0. Then highlight the 1 point. Then highlight equal to 0. Then this one no need to highlight at all and put lesser than 0. This one is no intersection. So this one is quite similar, quite easy on this discriminant. Now let's move on to the next part, the fun part. Okay, this part of the notes, you all can keep behind your circles. There's a blank space you all can write down. The next one is called location of point. The heading is called location of point. Now, what is this location of point about? This location of point, right, can only have 3 locations. It's either inside the circle, on the circle, or outside the circle. Means there's only 3 scenarios. So I'm going to teach you all these 3 scenarios right now. Okay, so you can go and draw your 3 circles. Okay, so right now, remember for circle, there's always a very crucial point. What's the very crucial point that you just went through just now? The center. So let's all locate the center. Center, center, center. I call this as C, C, and C. Guys, so now I don't want you to make your notes, okay? So you all just listen carefully first. Later I'll give you a chance to make your notes. So now, you can see, right, the center is the one in red, which is represented by C, and the P is the point, which is the black dot. Now, what is happening is that right now, sometimes the question will ask you, hey, is point P located inside the circle, on the circle, or outside the circle? So how are we going to determine? So if you want to determine, right, we actually need to go and find the length CP. Okay? You see here, the length CP. Here is the length CP. And here is the length CP. Oops. Okay? So we always need to go and find the length of CP. Okay, now you all can make your notes. Length of CP and length of CP. Okay, so we found the length of CP, right? Now, guys, make a guess. We are finding the length of CP with comparison to who? Very good. So we are comparing it with the radius. So I'm going to change color. My radius will be from here to here, correct? My radius is from here to here, right? And my radius is from here to here. So the blue one is all my radius. Radius, radius, radius. Now the first scenario, what do y'all notice? The length of CP is what than the radius? So what do I write? What's the symbol to represent? Less than. So when you notice that the length of CP is less than radius, what can you say already? Therefore, you can say that the point P is what? Inside. Yes, it's inside the circle. Okay, now let's move on to the next one. What do you notice about the length of CP and the radius? Is what? Same. Same means what symbol? Equal. So we know that. Therefore, the point P is where, guys? On the circle. Last one. The length of CP and the radius. What do you notice about the length of CP and your radius? More than, yeah. So when it's more than, therefore we can say that the point P is, yes, it's outside the circle. Now you can take your highlighter and then you can highlight it out. More than means inside. Equal means on. Less than is inside. Equal is on. And more than is outside. Now you can make your notes. Okay, so the next concept, right, we are going to learn, you can write down the heading. Just now was location of points. So now the heading is having X and Y axis as tangents. Oh, shoot. I realized before I teach you X and Y axis as tangent, I need to teach you one more concept. Yeah, I need to teach you one more concept. I suddenly remembered. Okay, so what is one more concept that I need to teach you all? It's something that I and Carrie both y'all learned yesterday already. So let's do a recap. Okay, we'll do more in depth. Okay, so we have a circle here, and we have a tangent. Can you see that? So this is called the CRT concept. C, which is your center, your radius, and your tangent. So what does this CRT means? So it means that these three, right, they are best friends. They come together. C, R, and T, okay? Center, radius, and tangent. Now, this CRT concept, whenever you have a radius and tangent, we know that there is a 90 degrees. Can you see here? They are perpendicular. Okay, they go together. So usually perpendicular, we know this concept that another concept that we're going to use is that the product of gradient. Equal to -1. Yeah, so that is a CRT. Always remember, wherever they have radius, you need to know that radius go with tangent, and then the product of gradient is -1. So this is one of the concepts that you all need to know. Okay, now the next concept you need to know is, okay, this thing called what? What's this thing? What's this thing that I'm going to highlight in pink? What is it called? Yes, this is called a chord. So write that down. This is called a chord. Okay, so now what happens with this chord? It comes with the center too. So center and chord is called a CC. Okay, what is this CC? CC, you need to know it forms two things. CC will give you this one. What is this blue line called? Anybody know? This blue line is called something. Yes, very good. It's called your perpendicular bisector. Now, what's so special about this perpendicular bisector? What does it do? for this perpendicular bisector. What do you notice this perpendicular bisector do with the chord? It divided by 2, is it? We just said that. Okay, so what does that mean? There are two concepts we'll know already. What's number one? Okay, there's a 90 degrees. Yes, number one, there's a 90 degrees. This is number one. Means we know the product of gradient is also -1, right? What else we know? What else do we know? Any more? Any more that we know? Yes, very good. Midpoint. Number two, because perpendicular bisector is always two things. It's always the 90 degrees one and the midpoint. So we can find this person, this green dot here, the midpoint. What else do we know? We know one more, one last one. One more that we know. Especially you got to do your perpendicular bisector and a chord. What do you notice? You can figure out one more. Yes, both lengths are the same. This length here and this length here. Okay? So this is what happens when there is a chord. CCPM, I call it. Why CCPM? C stands for chord, center, perpendicular bisector, and midpoint. So this is a CCPM. So one is a CRT and one is a CCPM method. So always remember this, okay? Especially the CCPM, you're going to see it very often. You know, a lot of your circus question. Okay, so now with these two concepts that you guys know, we're going to move on to having X and Y axis as the tangent. All right, so right now we're going to do the next part that is having X and Y axis as tangent. So now, guys, if it's tangent, immediately what comes to your head? CRT or CCPM? Yes, CRT. Now, why CRT? Because tangent always go with who? Who is the partner of tangent? Radius. So can you see I got center, C, and the tangent. So this will be my R, right? So this is my radius. So CRT, what does CRT means? When you have radius and tangent, what happens? We know that it is 90 degrees. Okay? So that means, right, do you notice I can actually find something about my center? For example, guys, look at here. This is your circle, right? Over here. Then this is my center, right? So let's say this person here and this person here. My center Can you see if this is my radius and my radius? Can you see? These two are both my radius, right? So if these two are both my radius, do you notice that my center, to find the coordinate of center, what would it be already? What would the coordinate of my center be? Yes, R comma R. You understand now? So in, let's say, in a scenario where your teacher tells you, right, of X and Y axis as tangent, means this circle, right, is touching both X and Y axis, means your center is RR. Okay? You understand now? Now, I'll go more in depth. The next one is, let's change color. And this person right here is my x-axis. X-axis as tangent. So it means that this person is also my R because it's a CRT concept. And then I have 90 degrees here. So with this concept, I know that my radius, my center, is R comma R. What do you think the first R? The first R is actually the X, right? So the X value. And then the second one is the Y value. And they're both RR. Okay, so now I'm going to introduce a new person, a new line. So this, let's say now I have a curve here. Oops. Now, this curve cuts through, so let's say my curve is y is equal to 1/3 x squared. And they say that it cuts through the center. Now, from here concept, we know that the center is RR. And we know that the radius is R. Right, guys? So if I want to find, so I know that, can you see the center? The center RR lies on y is equal to 1/3 x squared. Correct now, guys? So let's say I want to find the value of R, what must I do? I actually need to sub this into here. You understand? Because I know the center for sure is going to be RR. So I know that right now it will become, from here, I know that y is equal to 1/3 x squared. So R is equal to 1/3 R squared. Then you can continue solving to find your R value. So from here, you can find your center, you can find your radius. You all get it? Understand? So take a while to digest this, then can make all this as notes. So this is a question type, one of the question type the teacher like to test. Then later, I'm going to move on to 2 more question types. That will be almost done. All right, so I have 2 more types to teach. Now, one is called reflection. So this one, I need you guys to really, really listen very, very carefully. So you can write that down as reflection. Now, reflection, there are 3 types. I'm going to do the first type with you guys. Now, the first type is called the y-axis. So this is the y-axis, yeah? Now, let's say I have a circle here. When it reflected, it will definitely be here. Correct now, guys? So what is happening here, right, is that I want you guys to take note. Wherever it comes to do reflection, remember circle, I told you all there's 2 types. The 2 things you need to know about circle. What is the 2 things you always need to know about circle? Yes, the center and the radius. Let me ask you, if let's say the circle is being reflected, will the center change? So this is the original, this is the OG, and this is the reflected. Will the center change, or do they still be the same? Will it change or be the same as the OG? You say the same. So let's say here, what is the center here? Let's say this is my x and y axis. What do you think it makes sense for this center to be? Anybody can give me a random number? Huh? -4 and? -4 and 2. So do you think here will also be -4 and 2? Yes or no? So do you think it makes sense? Yeah, it doesn't. So will the center change? The center will change, right? But what about the radius? Will the radius change? When it reflects, does it become bigger or smaller? It will still be the same. So over here, the center will change. Will be a different answer. But the radius, what about the radius? The radius will? Yes. Okay, so this is a concept that you need to know. Now, when it comes to y-axis, there's y-axis, there is x-axis. Now, whenever it comes to y-axis, guys, please take note, we don't focus on the x-axis. So y-axis, we just only focus on the y-axis, okay? Now, guys, can you see I'm going to eliminate a lot. If let's say the question say is being reflected on the y-axis, you know what I will do? I'll just draw number 1, the y-axis. Number 2, I will only have the center of the OG. This is the OG, the center only. And then here is the reflected center. Can you see that? Can you see that I don't even bother drawing my circle and the radius? I don't care because I know the radius will be the same. Why waste time to draw the center and the radius when it's gonna be so complex? You understand now? Okay, now listen carefully. Later then you'll make notes. So now the next part is this one. So you understand what I just did there, right? I didn't do much. I just, when it says reflected, do I even care about the x-axis? Yes or no? I don't care, right? And then I only draw the y-axis and I only focus on the center, okay? So can you see the distance here? So do you notice that the distance between the y-axis will be the same? Correct? The distance between the y-axis is not the distance between the y-axis. The distance between the y-axis is the same. So if the distance between the y-axis is the same, are we looking at the x-axis value or the y-axis value? So let's say over here is -4,2. I know the distance is the same. So should I be focusing on -4 or should I be focusing on 2? Which one should I be focusing on? Yes. Wait, let me write in pink. -4 and 2, for example. So I'll only be focusing on who? -4, because the distance is the same. So I know that here is 4 units. This is 4 units away from the y-axis, right? So it means that on the right-hand side is also going to be how many units away from the y-axis? 4 units. So from here, I know that what is my center already. Can I find my center? The reflected part? Yes, it will be 4. How get 4? You can just take -4 plus 4 plus 4. Got it? So here is -4 plus 4 plus 4. And that's how I get 4. Then what do you notice about the 2? Can you see the 2 is the same? Because it's just a reflection. Got it now? Okay, now you all can make the notes. Yeah. Anything up to you. You can draw it on top for easier visualization. But take note, whenever we do a reflection, right, we only focus on the y-axis and the center. I don't even bother drawing the circle at all because it's just going to confuse me. Because I know that the radius will be the same. Oh dear, I realized I'm still recording. Okay, so the next part we're gonna do is a reflection on the the x-axis. So this is type 2. Let's say I'm going to give you a more complicated one. Means something that is overlapping. Okay. We have a big circle and a small circle. So can you see if you draw like what I drew, right? You'll be so confused. So this is right now, it is reflection on the x-axis, right? So when it's reflected on the x-axis, guys, what do I care? What will I draw now? Will I draw everything? I'll just focus on drawing what first? Okay, well, beside the center, I need to draw something first. I need to focus on drawing the who first. The what? Radius? No, I don't care about radius also. I focus on who first. Look, look at the one I draw in pink. What do I do first? So who do I need to draw? I focus on drawing who first. Okay, so this is the OG and this is the reflected. But what do I need to draw first? What do I need to focus on? Focus on drawing the who first. That's the later part. That's the one in green. I do that later. But I need to do who first. Okay, but is this a y-axis question? So I draw the who first. Yes, I draw the x-axis first. Okay, so this is the x-axis. Now I draw who next. I focus on drawing who next. Center of who. So if I know that this is the center of the OG, the original, so this is the center of the OG means I can draw the who. Yeah, so this is the reflected. So this is the reflected center. You guys get it? So can you see that I don't even care about like the rest? I just focus on drawing my x-axis and drawing my OG center and reflected center. So now I can go and find out the one in green. So the one in green is what? What do you notice? The distance between the x-axis is the same, right? Correct? And the distance between here is the same. So the distance between the x-axis is the same, but I look at the y or the x. Yes, I look at the y. Then over here, I write down, I look at the x. So later you can add on, look at x. Okay, so let's say for example, over here, right now, I'm going to give the same example. Over here, it's 4, 2. 4, 2. Okay, so right now here is 4, 2. So right now, we look at the x or the y now. We'll be looking at the y. So now will the y will be changed, right? So what do you notice about the distance of the y? Since we know it's 2 means what? Yes, it means that it's 2 units. So here is 2 units means this person is also 2 units, correct? So how do we find this person then? To get this person is actually 2, what? 2 minus 2 minus 2. So the answer is -2. And then what else? Will the x change? So the x will still be 4. It doesn't change. You guys understand this concept? So you see, right? Once you get the center, the radius, you know, is the same as the OG, which definitely for sure the question will give you. And then you can go and find your equation of your reflected circle already. That's it. So this is the part that students always get confused. So you all can make your notes for this too. And then later we'll move on to type 3. So this is type 1 and type 2. Type 1. And this is type 2. So later I'll do type 3. Now the last type, okay, is this person. So what is this line? This line is called y equal to x. Now before I tell you how does y equal to x line look like, I want you all to draw and then show me. Let's see whether you all know how does y equal to x line look like. Okay, draw it on your notes and then show it to me. Yes, very good. Shilong got it right. Yes, very good. You got it right too. Yes, everybody got it right. Very good. So everybody know that this is the line y equal to x. So you need to know that y equal to x, right, means, for example, if here is 2, here is 2, right? Means it's equally spaced, correct or not? If here it's 1, here is 1, right? So you all understand this part. So let's say right now, my center is around here. So if it's around here, means I know my reflection is around here, correct? And I know that this and this is also equally spaced. And they're 90 degrees. Correct now, guys? So with that, you should be able to find the reflected part also, because they are the same. So if, let's say over here, let's say it's -4,2. So what do you think this will be then? If this is -4,2, so this person would be how much? Here is -4. And here will be how much? Chinong, you said? Yes, and? Yes. So this is how you do it. So this is the OG and this is the reflected. And that's the last part. They're going to teach you one more last concept and then we are officially done with almost the whole crash course of amath circles. Okay, so guys, temporarily I'll put Trigo on hold first, okay? I'll do amath circles because apparently I heard that for you two, you'll be tested on amath circles. Yeah, did anyone tell you that? Yeah, so I heard that you guys are tested, and then Jinlong, you're not tested, but then you have already learned this already, right? Yeah, so I think I see a need for me to teach you guys, just in case later your teacher change your mind, decide to test you all on circles. Okay, so I put a hold on Trigo. So by right, actually, you need to learn Trigo first, then you can do circles. Because if you look at my Math Munchies book, right, in order to do circles, you must know Trigo also. Yeah. So it's a combination, but never mind. We'll just do this one first. Okay. So the next part we're going to learn, the last one is the sketching. Okay, so right now, right, always remember, guys, whenever you want to do circus question, you must learn how to sketch. Now, don't worry on learning how to sketch. I just teach you guys. Sketching got 4 critical points. Okay? So the last part is sketching. For this sketching, you just need to know critical points. The concept of these 4 critical points. Okay, so what is all these 4 critical points? So right now, I will do this. This is my center. So if this is my center, to find 4 critical points, right, means, right, you need to at least have the center. You need to have at least the radius. So I'm going to have the center. Let's say my center right now, I give you is 4, -7. Okay? And then I give you 4, -7. Then I tell you that, hey, my radius is 3. Okay? So now, 4 critical points. Where are the 4 critical points? I'm going to do the first critical point for you. So I'm going to do the extreme left. I call this as the extreme left. And I'm going to have an extreme right. So what do you notice about the extreme left and the extreme right? If I want to find the coordinates, what is equal? It's something to do with the coordinates. You just need to know the coordinates. What do you notice about the coordinates? The y coordinate is the same. Anybody else? Is that the y coordinates? Do you think the y coordinate is the same? Do you all agree? Anybody agree? So she's telling you that this person is -7. And here is also -7. Do you all agree? All agree, yeah? Okay. So that means that how are we going to find? So it means that the x coordinate, will it be the same or no? Okay, it will not be the same. So how are we going to find the extreme left value for the x coordinate? Yes, how you know that this person must -3? Yes, the radius is 3. So this person will be how much now? 1. Then after that, how do you find the extreme right value? Yes, 3. And the answer is 7. Okay, so I give you some time to make notes first before I move on to the next 2 critical points. Okay, so the next part we're going to do is this part here. Super important. Now, this is not called the extreme top, okay? What do you think it is? You learned something before already. What do you think this is called? Not the extreme top. What kind of point is this? You learned your quadratic curve before. Yes, so this is called your maximum point. Okay, then what about here? This is called your what? Yes, this will then be called your minimum point. Okay, so what do you notice about your maximum point and your minimum point? What is the same? Yes, the x will all be the same. Okay, so from here, we can go and find the y value. So how are we going to find the y value then? We look at the x or the y of the center. The y of the center, okay? What do we do with the y of the center to get this point? What do we get now? -4. Then what about here? Draw pointing to here. -3, okay? So what would be the y value then? Yes, and with that, you guys have kind of mastered almost everything for circles. The end.